Well, hey everybody, Mr. Reeves back with you, and in this video we're going to be talking about writing and solving two-step equations. Alright, so I am in lesson 6.3 in your Accelerated Math 7 textbook, which is on writing two-step equations. Alright, so they've got here first a question where they're asking you to use algebra tiles to model 3x minus 4 equals 5. So I'm going to jump over here to my algebra tiles demonstration. Again, 3x. So these are my x bars here. So there's 1, 2. So there's 3x. All right, and then what did we want? We wanted 3x plus or minus 4 equals negative 5. So since I want minus 4, then I'm going to use negative algebra tiles, because technically what we're doing is we're adding negatives, because adding negatives is the same as subtracting positives. So there's 3x minus 4, and then what's the last thing I need? I need equals 5. So now I'm going to put positive 5. 1, 2, 3, 4, and 5. So there would be my equation. All right, now to solve that equation, remember what we want to do is we want to do the opposite operations in the opposite order. So generally we're adding or subtracting first. So in algebra tiles, that means we get rid of these ones here, and then we divide. All right, so remember we added negative 4. All right, so we could take those away with algebra tiles, but we don't have any to take away over here. So generally, the better thing to do is to add yellows here. And so we're going to add the same thing to each side. Now, I happen to know that they will run out, so I'm going to use the copy option. 1, 2, 3, 4. All right, so here we go. 1, I don't think I quite got all 4 here. 2, I had 5, right? So let me go ahead and copy a couple more here. All right, so there's 4 added on that side, and now I need 4 on that side. There we go, right? Again, I might as well make them look the same. Okay, so there's the 4 that I added to each side. Now, when you subtract 4 and then add 4, those inverses are going to cancel each other out, right? That's why we did it. There we go. They cancel each other out. And now we are left with 3x's are equal to 9. Now we're ready to divide by 3. All right, so I'm just going to grab these ones and I'm going to divide them evenly among the 3 over here. I know this kind of violates the idea of the left-right thing here, but I think you guys get the idea. We can do it up and down as well. All right. And then you could see that when it's broken up into, whoops, what happened? I somehow had an extra one there. All right, well, we'll get rid of that guy. Ka-chow, gone. All right, because we had 9, right? We had 5 plus 4, which is 9, 3, 6, 9. Then what do we get? We get x is equal to 3. X is equal to 3. So that is how you create and solve that problem using algebra tiles. Now, if we weren't using algebra tiles, of course, if we have this problem, 3x minus 4 is equal to 5 here. I'm going to rewrite it right here. 3x minus 4 is equal to 5. Doing it without algebra tiles, we would add 4 to both sides, because the opposite or the inverse of subtracting 4 is adding 4. Those would cancel. And then we would get 3x is equal to 9, right? And then we would divide by 3, because the inverse of multiplying by 3 is dividing by 3. And we would get x is equal to 3. The same answer, of course, that we got over here with our algebra tiles. X is equal to 3. All right? So that is creating and solving a problem with algebra tiles. All right, so let's talk about modeling word problems, excuse me. All right, so they're going to be giving you problems. They're going to be asking you to write equations, and then ultimately, of course, you're going to have to solve those equations. So if you take a look at this problem they have here, a 1-year membership to Metro Gym costs $460. There is a fee of $40 when you join, and the rest is paid monthly. Write an equation to represent the situation that can help members to find out how much they pay per month. All right, so take a look at a couple things here, all right, that are going to be common in a lot of these word problems. All right, this right here, that $460, that represents a total, okay? Many times you're going to have some kind of problem that's going to involve a total. So right off the bat, I'm thinking it's going to equal 460. That is equal to my total. All right. Sometimes if you're removing amounts, then that would be the remaining amount, but many times it's going to be a total. Now, there's also this thing right here, which is a fee. Many of these problems are going to have a one-time fee or a one-time cost. Why is that important to focus on the fact that it's one time? That tells us it's not going to have a variable attached to it. It's a one-time event. All right, so that means there we have that $40 is part of the cost, but it only occurs one time. It doesn't repeat. All right, and then right here, the rest is paid monthly. All right, now that is a recurring. Sorry, let me see if I can write this a little bit neater. RECURRRING. That is a recurring cost, and since it's monthly, we happen to know there are 12 months in most years. All right, and so that would occur 12 times. The recurring cost, that is what's going to get. When you have something recurring, that is where you're going to have your variable. All right. Remember, a variable is a letter used to represent either a changing value or something we don't know. All right, so that's our other clue about what the variable is going to be, because at the end of most problems, and usually it's always at the end, it tells you what you're trying to find. What we're trying to find is how much they pay per month. All right, so that's going to be our variable, and there are 12 months. So if we go down to where they wrote the equation, here we go. One-time joining fee of $4 plus, right, because we're adding all this together. Here's our total of $460 over here. 12 times the monthly cost. So here is our reoccurring cost here. How many times does it reoccur? 12 times. So there would be our equation. 40 plus 12m equals 460. Now, they didn't ask us to solve it, but we're going to go ahead and solve it here. The first thing I'm going to do is take that 40 away from both sides, all right, because we're going to do the opposite operations in the opposite order. If we were going forwards, we would multiply by 12 and then add 40. So going backwards, we subtract 40. That gives me 12m is equal to 420. Okay, now I'm going to divide by 12. All right, so m is equal to, let's go ahead and do the math over here. 420 divided by 12. 12 goes into 42, what, 3 times? 36, right? 42 minus 36 is 6. Bring down that 0. 12 goes into 65 times. So m is equal to 35, which means for this problem it would be $35 per month. Okay? So again, just a reminder, okay? That one-time fee, don't attach a variable to it, all right? That reoccurring cost, that's what's going to have the variable. And then the question simply is, how many times does it reoccur? Or sometimes they'll make the variable the number of times it reoccurs, and you'll actually know what the cost is. Okay? All right, so let's go ahead and just take a look at some problems that they offer us in the problem set. All right, I'm not going to go through any more algebra tile problems. I did a whole nother video if you're interested on solving equations with algebra tiles. So if you want more information on algebra tiles, go back and watch that video. All right, here we go. So number 3 here says a group of adults plus one child attend a movie at Cineplex 15. Tickets cost $9 for adults and $6 for children. The total cost for the movie is $78. Write an equation to find the number of adults in the group. All right, couple things. Think back to what I told you. Here we go. There is our total. So right off the bat, I'm looking for equals 78. That's where I like to start. For me, that's the easiest part when you have a total, just to say what it's equal to. All right, now I'm going to look for, okay, what is it that I don't know? What is it that they're asking me to find? Write an equation to find the number of adults in the group. So that's going to be my variable. That is my unknown. Now, sometimes they'll tell you what letter to use. They didn't tell us to use what letter, so I'm going to call that A. All right? So I'm going to make that A equals the number of adults in the group. All right, now, what did they tell us? A number of adults, that's our unknown, right? Again, that is our A. We don't know what that is. But we do know there's one child, right? So we have A adults and one child. So A equals the number of adults, right? All right. 1 equals the number of children. Now, when you walk up to that window to pay, assuming you didn't pay online already, all right, tickets cost $9 for adults and $6 for children. So we know for the children part, it's 6 times 1. One child at $6, right? For the adults, it's 9. 9 adults, but we don't know how many adults went, so it's A. All right? So our equation, if we clean it up, becomes 9A plus 6 is equal to 78. 9A plus 6 equals 78. In fact, let me go ahead and rewrite it up here so I can solve it. What would I do to solve it? Well, they added 6, so I'm going to subtract 6. What I'm really doing in the context of the problem is I'm taking away what we paid for that one child and saying now everything that we have here is just for the cost for the adults. We divide by 9 and we get A is equal to 8. All right, so there were 8 adults. There were 8 adults in the group and one child. All right, by the way, those are killer prices for movies. Must be a matinee or something. All righty. Let's go ahead and go to another problem over here. All right. Val rented a bicycle while she was on vacation. She paid a flat rental fee of $55 plus $8.50 for each day. The total cost was $123. All right, so here we go. There's my total cost right there, equals 123. All right, find the number of days she rented the bicycle. That's going to be my variable. All right, so D is the number of days. All right, she paid a flat rental fee of $55. That's my one-time cost, right? That's the one that does not get the variable. 55 plus, now what is she paying? She's paying $8.50 every day. Now, how many days did she rent it? We don't know. That's why we assigned it a variable. So there's our equation. Let me scoot this over here. All right, 123. So $55 plus $8.50 per day is 123. Now, usually what we would do is we would write it like this. We would drop the 0, and we would write it like this, right? Okay, then what am I going to do? I'm going to subtract 55. I take away that one-time fee, and when I do that, that will tell me how much she paid strictly on the per day fees, right? Take away that fee. All right, here we go. 13 minus 5 is 8. 11 minus 5 is 6, right? And then I divide by 8.5. All right, so here we go. 8.5, you know what? I'm going to get out my handy-dandy calculator here. So I'm going to have 68 divided by 8.5. Well, I know 8 times 8 is 64. So it's going to be somewhere in the ballpark there. All right, so I'm going to do 68 divided by 8.5. Whoops. Let me try that again. 68 divided by 8.5. And when I do that, I get 8. Look at that. I should have just done it. All right, D is equal to 8. So the answer to that question would be 8 days. All right, let's set a couple more up. I probably won't solve them, but we'll set them up and then we'll be done. A restaurant sells a coffee refill mug for $6.75. Each refill costs $1.25. Last month, Keith spent $31.75 on a mug and refills. Write the equation. All right, so here's my total, right? My total is $31.75. Find the number of refills that Keith bought. All right, that's my variable. I'm going to call that R. Do we have a one-time fee here? All right, he bought the mug for $6.75. That's a one-time fee for the mug. All right, you guys know a lot of times they do that, though. You can buy, if you go to like Six Flags or something, you buy that cup and then they give you free refills or they charge you 25 cents or something for a refill. All right, each refill is $1.25. How many refills did we get? We don't know. So that would be our equation right there. Again, there's our total, there's our one-time fee, there's our recurring cost, and that's how many times it recurs. And again, to solve it, I would subtract $6.75 and then divide by $1.25. All right, here we go. Last one. A gym holds one 60-minute exercise class on Saturdays and several 45-minute classes during the week. Last week, all the classes lasted a total of 285 minutes. All right, so there's my total. My total of 285. It has 160 minutes. There's our one-time occurring thing. All right, what don't we know? The number of weekday classes. All right, so I'm going to call that W, the number of weekday classes. And those classes are 60 minutes. Or I'm sorry, those classes are 45 minutes each. All right, so here's our one-time Saturday class. Here's our reoccurring several times during the week, 45 minutes each, times the variable, because we don't know how many times, and there's our total. And again, to solve this, we would subtract 60 and then divide by 45. All right, so that's it for this video. Again, the section I was working on was the writing two-step equations, but of course we've talked about solving two-step equations already. Honestly, the writing part is the more difficult part, which is why we saved it for second. Like I've said before, I don't always understand the order that your book put things in, but I'm sure they have good reason. All right, till next time, see ya.